Warahmatullahi wabarakatuh. Perkenalkan nama saya Bakthi Ananda Harisona dengan NIM 243433085. Sekarang saya akan menjelaskan tentang software requirements yang mana pada Swaybook ada pada chapter 1. Okay, right here, my name is Bakthi Ananda Harisona and I am going to explain about software requirements which in Swaybook is in chapter 1. Okay, so what is software requirements? Software requirements is a condition or a capability needed by users to solve a problem or achieve an objective. A condition or a capability that must be met or possessed by a system or system component to satisfy a contract, standard, specification, or other formally imposed document. So we can say that software requirements is of a set of written condition that already been talked about that the system need to have. So here are the categories of the software, the requirements itself. So there is software project requirements, software product requirements, functional and non-functional requirements, and lastly, technology constraints and also quality of service constraints. Uh, Here I will also explain these categories one by one. So first, I'm going to explain about software project and product requirements. So, software product requirements is a requirements that specify what the software should look like, how it should fit, and what it should do. But software project requirements constrain how the project is run, including the cost, the schedule, staffing, and the tools. So, uh, here are the two requirements. One focus more on the software, on what it should do and what should it look like, and software project is the technical background about the cost, scheduling, staffing, and the tools used in the project itself. Okay, next we got the functional and non-functional requirements. The functional requirements specify the observable behaviors, policies, and process the software must execute, or to put it lightly, what the system does. So, and also the non-functional one, the requirements specify the technological constraints, platform, and quality of service standards the software must adhere to. To put it lightly, it is how the system performs. Okay, next is the technology constraints. Here are also one of the categories in the software requirements. Technology constraints specify the exact name hardware, software, or tools that the system must use or is prohibited from using. Examples such as specific OS, programming language, or database engines. Next. The last one in the categories is quality of service constraints. Quality of service constraints specify the acceptable performance levels the system must achieve without naming specific technology. Example, uh, the response time, reliability, scalability, and also security. Next. Uh, we already talked about the categories, but also how or why does it categorize that way? Here are six reasons of why. First one, requirements in one category tend to come from different sources than other categories. Second one, elicitation techniques often vary by source. Analysis techniques may vary by categories. Specification techniques vary by categories. validation authorities vary by category. And the last reason is the different category affect the resulting software in different ways. Okay. Next, we will talk about requirements elicitation. So, what is requirements elicitation? Elicitation active process is the active process of discovering and capturing candidate requirement from various sources to minimize incompleteness in a software project. So, the elicitation is how we got uh, the requirements itself. From where do we got it, and how is the process? Requirements sources are people. So we got the requirements from source, and the sources are the people such as the stakeholders, such like client, users, or expert in the field, and non-human assets such as documentation, existing system, and business context from which the requirements are gathered. So it's not only gathered uh, from humans such as client, user, or expert. We we also look at the documentation and also existing system, the similar system that we want to achieve or want to build. Next, the common requirements elicitation techniques. Common requirement elicitation techniques are the specific methods. So, the technique that we do elicitation with is like interviews, workshop, prototyping, and direct observation used by software engineers to extract both explicit and hidden requirements. Next, we will talk about requirement analysis. So, first, what is requirement analysis? Requirement analysis is the process of investigating elicited information to fully understand individual requirements, determine their implication, and fit them contextually into the overall system. Formal analysis uses a mathematical defined specification language to ensure requirements are precise, concise, and capable of static verification to prove system safety and logic. So here is the process of analyzing the requirements that we got individually. So the basic requirement analysis. Basic requirement analysis filter raw stakeholder feedback into engineering ready specification. Individually, it ensures each requirement is unambiguous. So it has one clear meaning and isn't ambiguous, and also testable, so we can verify it after an atomic, a single decision. Globally, it guarantees the entire collection is complete. So it also covers the edge cases, consistent. So it contains no conflicting rules and also feasible, buildable within a real world time, and tech constraints. So next we will talk about requirement specification. So what is requirement specification? Requirement specification is the systematic process of recording and documenting requirements so they can accurately remember, communicated, and managed over the software life cycle. Here, in requirement specification, there are two-way to do it. First, structured and unstructured natural language specification. First, unstructured natural language specification is how we express the requirements as a simple, informal collection of ordinary, everyday sentences. Please ignore this typo. This should be unstructured. So we can say that unstructured natural language specification is the informal collection of ordinary everyday sentences, such as the system shall, the system should, such as like that. And also, the opposite one is structured natural language specification. This enforces predefined text formats such as actor, action templates, use case fill, or user stories to increase clarity and precision. So, this is this two-way is just how we write it. First one is unstructured. This one is the sentence we use every day, and also the structured one use the formal way, such as actor action template, use case fill, or user stories to increase the clarity. Okay, next one we got model-based specification. Model-based specification replaces or complement traditional text document by using standardized visual modeling languages such as the Unified Modeling Language or UML for software or SysML for entire system to create a precise blueprint of the software instead of relying on long paragraph of the natural language which can easily be misinterpreted. It divides the system requirements into two clear graphical categories. First is the structural model and behavioral model. Don't worry, I will explain this in the next slide. Okay, next, we got the graphical categories, the structural models, and also the behavioral models. The structural models, these define the static rules and structural policies of the system, essentially mapping out what entities exist and how they relate to one another, such as conceptual data models or class diagrams or entity relationship diagrams. And next, we got the behavioral models. This define the dynamic behavioral processes, mapping out how the system react to data, changes state, and execute function over time. This one, use cases, sequence diagram, and also activity flowchart. Next, we got requirement validation. Okay, so what is requirement validation? Requirements validation is the process of gaining confidence that the documented requirements accurately represent the stakeholders' true need, ensuring they are complete, consistent, and understandable before development begins. First one, we need to understand what is requirements review. Requirements review is a collaborative validation method where diverse reviewers, such as the clients, the users, and the developers themselves, inspect the requirements document to catch the errors, omission, and deviation from standard practices. Next, we got simulation and execution. Simulation and execution is a technique where executable or formal specifications are walked through using demonstration scenarios, allowing non-technical stakeholders to see exactly how their policies will play out. Next, prototype. This one is one of the largely taught area in software engineer. Prototyping is the practice of building a concrete functional mock-up, such as the animated user interfaces. This one we can use with Figma or other software, so we can make the animated. So we can make the animated user interface. Uh, Prototype is to test the engineer interpretation of requirements and extract immediate stakeholders' feedback. So we can present the prototype to the stakeholders so they can give us feedback. Next, we will talk about requirements management activities. So, requirements management activities is the ongoing process of maintaining and protecting the agreed upon requirements baseline over the software entire life cycle. There are three activities that we need to understand uh, in this topic. First is requirements scrubbing. Requirement scrubbing is the practice of filtering and trimming down requirements to the smallest, simplest set possible by eliminating out of scope, low ROI, or overly complex items. The second activities we need to understand is requirements change control. Requirements change control is a formal governance process used to evaluate, approve, track, and communicate modification to the established requirements baseline while managing their impact on project constraints. The third one and the last activities we need to understand is scope matching. Scope matching is the continuous act of balancing the total volume requirements against real world project constraints, ensuring the work never exceed the available budget, timeline, or team capacity. Okay, I guess that's all from my presentation about software requirements. Thank you so much for everyone's watching. Terima kasih banyak sudah menonton sampai akhir. Saya Bakti Ananda Harisona mengucapkan terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.